Okay, so we're looking at quadratic functions today. We're going to learn about its inverse. So quadratic functions, any function that's exponentiated to the second power. So x squared, it's a quadratic function. It's easy to get quadratic functions and exponential functions all mixed up. Let's take the case of 2 to the x. This is an exponential function. The variable is in the exponent. So when x is 1, we got 2 to the first power, which is 2. When x is 2, we have 2 to the second power, which is 4. When x is 3, we have 2 times 2 times 2, which is 8, and so on and so forth. By the time we have 2 to the sixth power, we have 64. Now x squared, or x to the second power, the variable is in the base. The exponent is constant at 2. So this one will decrease a little slower. So when x is 1, 1 times 1 is 1. 2 times 2 is 2. 3 times 3 is 9. 4 times 4 is 16. 5 squared is 25. So you can see that this one's going to increase quicker than this one. So exponential functions increase more rapidly than quadratic functions, unless their base is less than 1. So we're going to look at a problem where we have some cubes, and we are going to be stacking cubes to make a wall, and we are going to be painting one side of the said wall. So we got one cube. Let's look at this animation. Okay, well, we've got one cube and we've got one painted face. So we painted this side, so 1 went to 1. So how many faces of blocks will we be painting if we have a 2 by 2 array of blocks? So if we got one here, one here, one here. So for a total of 4. Okay, so we have 4 painted blocks here. So what if we increase the array over here? How many will we be painting if we have a 3 by 3 array? Okay, 9. Okay, so the process is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, so on. So we have 4 by 4, 4 squared, 16, 5 is 25. Okay, we want the general case. If we have an n by n array. So what is that going to look like? Think about it, instead of the number, think of the letter n. For each one of these, we raised it to power 2. We squared it. So n times n, that's n squared. N times n is n squared. So our function is f of n is n squared. If we graph this thing, we have this form. It's called a parabola. There are some parabolas on the back wall. They increase quickly, but not quite as quickly as exponential functions. So what if we knew the number of block faces painted and we want to get the height? So if we had 1 face painted, the height is 1. If we had 4, the height was 2. If we had 9 faces painted, the height was 3. Okay, if we had 16 that we had to paint, we would know that the height of the array was 4, as would it be its width. So if we had 36 to paint, what would be the height? Well, it would be 6. If we had 49, what would it be? It would be 7. So you may understand what's happening here. What operation are we applying? How do we go from 16 to 4? Or 25 to 5? It's called the square root function. Okay, whatever the argument is, we're looking for numbers such that if you multiplied it by itself would give you the original number. So if you multiply 7 by 7, you get 49. So you have to think of squaring in reverse. All right, well, let's plot these two functions. Here they're staying in the positive domain. So we switch the axes, switch y for x and x for y, and now we can plot its inverse. And of course, as always, you can see that the inverse is symmetric about y equals x. Okay, now, it doesn't really look like it's inverse because if you really reflected this across y equals x, you would have another branch here. Alright, so it turns out that x squared is only invertible when x is greater than 0. And the reason for that is when you put a negative number in the argument of a square root, there is no number that multiplied by itself will give you a negative number. Let me correct that. There is no real number. We're going to have to talk about complex numbers later on. But there is no real number that when you take the square root of it, gives you any number, any real number. Okay, so that should be enough information to go ahead and work on your student activity sheet. Today you don't have to complete all of it. I'll let you know what problem to stop at.